Hey guys, welcome to my introduction on the take-home assessment for Chapter 8. To start off, these are kind of math memes. I thought they were fun. So when I was in college, I took 2 classes on cryptography, which is sending coded message, and we looked at how math can be used for cryptography. So I had a couple pictures that, reminded me of those classes that I thought you guys might find entertaining. So here's a picture of Alice and Bob. Alice and Bob are trying to communicate. They're trying to talk to each other. So there's this idea in cryptography of like a public key where you put something out to the public and anyone can use that key to send secret messages. And there's also private keys, right? So different ways of communicating. For some reason, every cryptography problem always has Alice and Bob are trying to talk to each other, and that Eve, she's pretty darn annoying. She is the eavesdropper. Fun pun, right, guys? So that's something that always comes up in these kind of problems. This one I thought was a little bit more in line with what we're going to do for our take-home assessment. So, there's always... the message is like, "Hi, Bob," from Alice. She's trying to say hi to Bob, right? And Alice is red and Bob is blue because gender norms are stupid. So I'm going to make Alice blue. Here we go. Alice can like blue if she wants. And Bob can be like hot pink if he wants to. There we go. That's better. So Bob is sending Alice a message, or Alice is sending Bob a message saying, "Hey, Bob." So she encrypts her message, right? She does something. We are going to be encrypting our messages with a matrix, and then we're going to be able to decrypt it with a matrix, right? So you get your ciphertext, secret, weird letters that don't mean anything, or the numbers that don't mean anything. And your ciphertext is made by, you take your original message and you use some kind of a secret key to encrypt it. And then to decrypt it, you have to then kind of backtrack. So we're going to talk about how that happens. And I've got a little bit of an introduction. So there's a little bit of backstory here. It mentions the imitation game, if you've heard of it, which is based off of Alan Turing, who during World War II decrypted German intelligence codes for the British. And it was really, really crucial work that he did. It talks about what the basic concept of cryptography is, which is encoding using some kind of a key and decoding by anyone who knows the key. They can be really simple, they can be complex. The different types of cryptography, a lot of them, like I said, are mathematical in nature. It's not difficult to guess at the importance of this application. It is surmised that Hitler may well have won World War II had not a bright British mathematician been able to break the codes used by the Axis forces in their radio transmissions. Today, sensitive information is sent over the internet every second. Credit card numbers, personal information, bank accounts, etc. And when this information is sent, they typically encrypt it and decrypt it so that people who are trying to hack and steal information will not get your crucial bank account numbers and such. So we're going to look at a matrix encryption. The encoder is a matrix, and the decoder is its inverse. So let's see how this works. We're going to say that K is the key matrix. So I'm going to have K be the key matrix. We're going to have M be the message, and then C is going to be the coded matrix. So what will happen is we're going to take the key matrix, we're going to multiply it by our message matrix, and out will come the coded matrix. So you can think of it, it's going to be like a matrix multiplication problem. The note is that the sizes of K and M have to be consistent and will determine the size of C, right? So like based on your matrix multiplication properties and such. So if we let's say someone has C and knows K, so I have the coded message and I know what the key was, right? It's like a public key, and I want to recover the original message. So I know that k times m equals c, if I want to solve for the message, this is really similar to our matrix equations. We had a times x equals b. And remember, if we were trying to solve for what x was, I'll move that over a little bit to have some space. Remember, we multiplied both sides by the inverse of a, always on the left side, because as a reminder, when you're multiplying two matrices, the order is critical. So if I do the left side is where a inverse is, it has to be on the left side of both problems. Then remember, the inverse times the original matrix is your identity matrix. And the identity matrix is kind of like 1. Like identity times any matrix of the same size will give you back the original matrix. So this is the same process over here, except for switch the letters A, X, and B with K, M, and C. It's the same process that we're going to use the inverse of the key matrix times the coded message, and that will give us our original message in what they call plain text, like your normal letters. So we're going to do an example, and I'll kind of walk you through it. You can also skip ahead. You don't need to listen to everything in the video. You can read the sheet on your own. I'm just reading it with you guys. So if you wanted to encode the message, the eagle has landed, what you would do is you would take the letters, if we use like A is 1, B is 2, and so on, and translate all those letters into numbers. Okay? And then we need a key matrix. So here's a key matrix that we're going to use to encrypt and decrypt our message. Now, since it's a 4x4 matrix, we can only have 4 numbers at a time. So like if I take my first chunk of 4 numbers, 28, 5, and 0, I'm going to encode it. So here's my key matrix. Here are my letters. And then the reason why this multiplication works, because row times column equals the number, right? Row times column equals that number. And then you keep going, right? You do the next chunk, and then eventually you get this list of numbers, which is the message you have figured out, but you have coded it now. You've encrypted it. If you wanted to decode and solve back, you're going to use the inverse of matrix K. This is something you can do with your calculator, right? If you have your calculator and you're trying to find the inverse, just like a quick reminder, right? You would just do second matrix, pick your matrix, and then press that matrix button just without the second, and they'll give you the inverse. This one's kind of gross. Sorry about that, guys. And so if I have my inverse, I'm going to use my inverse, right? K inverse, and then times the first chunk of letters, and I'm going to use that to find what the original 4 letters were. Okay. So I've got to practice just to like see how we feel. So this one's kind of nice. This one we don't have to break up the letters in the chunks. I give you specific chunks that work out for the multiplication. So let's try this one together just to see if we understand how the multiplication works and everything. So here is my coded, right, matrix. Here is the key, that's K. So remember, if we want the message, we need the inverse of K times the coded message. So if I want to do that, let's kind of set it up. Just to note, a note is that the take-home assessment, I have you do the first one of this difficulty by hand, just so I can see, like, do you know how to do the processes by hand? And then from there on, I say just use your calculator to make it a faster process. So to do this, we need the inverse of K. So K inverse is going to be equal to, remember I need 1 over the determinant. 7 times 3 is 21. 9 times 2 is 18. So subtract those. Remember, we switch the 7 and the 3. The 9 and the 2 become opposite of whatever they were before. It's a terrible 7. There we go. 21 minus 18 is going to be a 3. So I'm going to rewrite that as a third. And then remember, we want to apply our scalar multiplication. So 3 times the third is 1. Negative 2/3, negative 3, and 7/3. And then from here, that's our K inverse. If I want the original message, I'm going to do K inverse times C. It's going to be this matrix times the coded message 165, 234, 187, 24, 213, 312, 246, and 36. Now this one's like a little bit cumbersome with some of the fractions, so I'm just going to show you guys this one with my calculator. That way the video is also not so long. So if I go in my matrix, I'm going to input the original matrix, the 160. I want to say that the coded matrix is 2 rows and 1, 2, 3, 4 columns, and I'm going to be putting in my coded ones at 165, 234, 187, 24, 213, 312, 246, 36. Okay, then I'm going to also input, so second matrix. Second matrix. I'm going to input as well my key matrix, the original one, so 7, 2. Oh my gosh, sorry. I'm having a moment, aren't I? It's a 2 by 2 matrix. I always do that. Do you guys do that too? It makes me feel better if you do it too. 5 and 3. Okay. So the first step is we want the inverse of the key. So second matrix. My key is the 2 by 2, so I'm going to choose B. Make it the inverse with the button that's same as the matrix button. And notice if I do math frac, that's the same thing that we got by hand. We're going to do that times second matrix. Matrix A is my coded. Remember, you want the inverse of the key times the coded message. So here are my numbers, 23, 26, 23. So I'm going to write them out. 23, 26, 23, 0, 2, 26, and I think it's at 13 and 12. Yes. Okay. Just a note, you also could have done that as well. You could have done second matrix, chosen the key matrix, pressed the inverse button, and immediately just done that times second matrix, matrix A. That would have also gotten you the same thing. So you can do it in one step rather than 2 on your calculator. Just a note, once again, I ask you to do the first one by hand rather than use your calculator, just so I can see, hey, I know how to find the inverse of a 2 by 2 matrix. And hey, I know how to do my multiplication step. So the first one on your take home you'll do by hand, and then from there out you can just do your calculator. And for your calculator, you honestly could just, write this if it's the calculator work, right? You could just write that and then give me the numbers that come out. So 23, if I look at my key, 23 is Y, 26 is A, 23 is Y again, 0 is a space. So I normally do spaces like slashes just to separate the letters more easily. Number 2, looking for number 2 in my key, is M. 26 is A, 13 is T, and hey, 12 is H. So your secret message was yay math. If you look at the next page, I had the answer here, just so you could double check your answers. So here is your official take-home assessment. This is the only part that you actually have to do. It's a take-home, so you can get help from other students, you can use your notes, you can use the internet. You just can't get help from older students, parents, or teachers. You're going to do the first group of letters to decode that by hand. So you're going to do that one by hand. And then from there on, you can use a calculator. But you want to write out what you're typing. You can call this coded, you can call this key. You can say I'm doing K inverse times C, and then write out what your numbers are, right? And then what you'll do is you'll do these groups of letters, these groups of letters, decode them. There are 8 groups, and what you'll do is at the last page you have a space to write out your secret message as you get it, and then you can formally write it out in words below. Now, I don't know if you guys caught this, but there is a version A, there's a version B, you see where it kind of indicates that it's different is at that point, and a version C. you will be assigned your version alphabetically, so look at Google Classroom for which one you have.